Hi everyone, good afternoon. My name is Kunal. I'm representing Gujarat Fluorochemicals today. I will be speaking on a topic, advanced materials for advanced technologies, majorly discussing about how semiconductor has been growing globally as well as in India, and then how GFL has been a pioneer in the fluoropolymer business in the semiconductor applications as well. One of my colleagues already shared a video on the corporate GFL that we are doing. I would just rush through a few points in it if someone missed something on that video. The Inox GFL group is majorly divided into two businesses. One is the chemical business, which comprises of companies like GFL, Gujarat Fluorochemicals, wherein we produce fluoropolymers like PTFE, PFA, FEP, and PVDF. Then we have another company called GFCL EV, which is a 100% subsidiary of GFL and involved in manufacturing of intermediate materials of CAM and electrolytes. Then we have also moved into the solar and green hydrogen energy. The other business vertical is on the renewable energy business, wherein we are a major player and integrated towards wind energy. The company is called Inox Wind. And then we have two more companies called Inox Green and Inox Wind Energy, wherein we are the O&M service suppliers. Just a gist of the entire group, Inox GFL, we are the leading fluoropolymer manufacturers in India with a market cap of more than $7 billion USD, and then the credit rating of AA positive given by CRISIL. We have more than 4,000 employees working with us globally, and with a prominent 30% CAGR growth, we have a 30 years of expertise in fluorine chemistry. Talking about our global presence, we are headquartered at Noida with our subsidiaries in Hamburg and Texas, with 4 manufacturing facilities, 3 being in Gujarat, wherein we produce all the bulk chemicals, fluoropolymers. And then we also have a fluorospar beneficiation unit in Morocco, which is a joint venture with the Moroccan government as well. Talking about the sales and distribution network, we are widely spread globally in different areas with warehouses in US, Europe, and sales and distribution networks in East and Southeast Asia as well. Talking about GFL's business verticals and the product portfolios that we have, the major portfolio is comprised of fluoropolymers, as I said, wherein we produce products like PVDF, PTFE, PFA, which I will also be discussing in the upcoming slide, which will be used in the semiconductor applications. Then we are also into specialty chemicals like first-gen CFCs and other bulk chemicals. Talking about the core competencies of the group, we have an integrated plant operations with manufacturing capabilities and a great global presence. The company is also excited and has been moving to new age products over the past few years, considering the growth and demand in semiconductors, green hydrogens. We have moved into EV battery chemicals, wherein we have 35% value of EV batteries and 50% values of electric vehicles. We have also moved into PVDF films for solar panels. We are extensively working in green hydrogen, whether be it proton exchange membranes or any kind of PFSA polymers. And then the semiconductors, which I will be discussing in depth today. We have been tapping all the semiconductor markets, not only in Asia, but globally as well. And we are also expecting that this market will be 2x by the year 2030. Talking about the brands that we have, you can see we have 4 major brands. The brand names are Inoflon, wherein we produce PTFE, PFA, and FEP. Then we have the rubber manufacturing Flonox, wherein we produce FKM, and now we've also introduced FFKM in that portfolio. Apart from that, we have also businesses in fluoropolymer additives and Inoflor, which is the manufacturing of PVDF. So I would just like to not deep dive completely, but give you an overall view of how the semiconductor industry has been booming for the past so many years. If you see these slides, you can clearly see from 2023, the global semiconductor market has grown from roughly around $526 billion to roughly around $627 in 2024. And with a CAGR of roughly around 7%, which is huge, it is expected to reach around $1,000 billion by 2030. And some speculations also say that this market could also value at 2 or 3 trillions in the coming years. Considering the revenues of semiconductor production equipments, you can see major Companies like Tokyo Electron, ASML, Screen, and Applied Materials have grown their businesses and portfolios over these years. The revenues have shot up drastically from 78 to 114 from 2020 to 23. And then again, the expected numbers are more than 230 by 2030. So the major drivers for these new industry applications would be 5G technologies, then we have cloud computing coming in, we have artificial intelligence, and then the use of smart and electric cars. And that's why we think that India is also going to be the next big thing in the semiconductor applications. Just understanding a little bit on the semiconductor value chain, it is valued roughly around USD 600 billion, which involves highly specialized players which have focus on different and specific aspects in this chip making value chain. You can see there are 4 to 5 different types of specific value chain additions that are there, starting from equipments, then there is wafer making, then there is fabless for manufacturing of these chips, then there are foundries, and then OSATs. I will also be discussing this value chain and wherein GFL sits in this value chain in the next slide as well. So each region in the global market contributes to a very distinctive specialization of the semiconductor value chain. If you see the European countries like the UK have a focus on licensing IPs, manufacturing the equipments and the materials used in these semiconductor applications. Then we have US, which dominates fabless chip making and designing EDA and IDM markets. Then the Asian market has been growing for the past so many years. We've seen countries like Japan, Korea, Taiwan, which have developed their own ecosystems for supply chain and manufacturing of these chips. The major segments would be OSAT in these Asian countries. The foundry is expected to be the more focused and profit-generating business out of all of these. And there are governments of Taiwan, South Korea, which have hugely invested in these foundry services. TSMC, which is one of the major larger players in this semiconductor division, has also announced an investment of $100 billion into additional chip making capacities. So we can see that the semiconductor growth is huge in the upcoming years. We'll see a lot more companies investing not only outside India, but then in India as well. So talking about these supply chain values that we have in different segments and different articulations, we have foundry market share dominated by Taiwanese companies, which is roughly around 63%. Then we have the fabless market share, roughly around 65%, which is predominantly dominated by the US. And then at an overall level, Asia Pacific also holds a large number of manufacturing units, and the share is roughly around 63%, followed by US. So talking about how this revolution of chip making and the application has changed over the past so many years. When it started in 2004 to 2007, we had a lot of complex mobiles coming in with basic internet services. So the chip making, the nodes that were used were roughly around 65 nanometers. Then we moved into logic-based components wherein the chips were made of nodes of roughly around 32 nanometers. The 2009 to 12 era saw a great deal of growth in PC market, and hence there was a demand of lower nodes of chips. Then we introduced the 22 nanometer globally. In 2012-15, there was a decline in PCs, but a huge involvement of smartphones, cars, and all these applications. And by 2021, you can see the 3 nanometer mode semiconductor chips are the most advanced and which will be used in performance improvements, power consumptions, and heat dissipation properties. So the Indian government has also been very active to take care of companies that want to put in some investments in India, whether be it OSAT, whether be it packaging, or the manufacturing of chips as well. We know that we are a little behind on technology on making 3 nanometer chips, but it is a good start for us. We have a lot of projects coming in, be it Tata's and other projects that I will also be discussing in the upcoming slides. So there are major 4 pointers that the Indian Semicon mission developed by the Indian government has been put in. The major vision is obviously to build a semiconductor ecosystem in India where we can innovate and packaging and manufacturing of these chips. Then the eligibility is for any company or joint venture that can have all these applications in their portfolio. The major objective would also be to attract large investments for setting up semiconductor wafer fabrication facilities across the country, and we've been seeing a lot of companies coming in this segment as well. Again, the tenure the government has decided for right now is for 6 years. There'll be benefits that the government will be providing for any companies putting up any kind of units in the semiconductor space. So just understanding why it is important that India has its own base for semiconductor manufacturing. We are a massive consumer of semiconductors, and the country accounts for roughly around 10 to 20% of the global demand, which is huge. So it is high time that we start manufacturing our own chips, having our own packaging units, and having our own supply chain and ecosystem. Just to give you an idea of it, one passenger vehicle which we travel in would require roughly around 10 to 200 different chips. So the demand is going to be huge, and this is only in the cars. Then we have smartphones coming in, then we have PCs coming in. So the demand is going to increase by twofolds. Currently, India relies mostly on imports and spends roughly around $24 billion each year on these semiconductor equipments and chips. And by 2030, the expected demand is going to reach roughly around $110 billion. So this expectation is for the Indian government that the India becomes a global player to develop these chip technologies in the next decade. I'll just go through this slide quickly. These are the schemes that the government has introduced for semiconductor applications, whether be it fabs if you're putting in, or there are display facilities, or design and packaging. Currently, we have a few investments coming in India by TEPL, which we all know is coming in Dholera. It's going to be the first fab facility with roughly around 50,000 wafers per month and huge investment of 91,000 crores. And the project is expected to end by the year of 2026. Then we have announcements by CG Power, which is an OSAT manufacturing company, which is also a good investment of 7,600 crores, and it is expected to end by next 3 years. Then we have TSPL coming in Assam, and global companies like Applied Materials, KLA, and Lam Research have also introduced their investments in the country as well. So the ongoing projects, Tata Electronics would be the largest one right now, wherein they would be manufacturing wafer fabrications with an investment of $12 billion. The timelines are 26, and applications would be automotives, computing, and data intelligence. Then we have companies like Adani, CG Power, and Tata Semiconductor, which will also follow the paths of Tata Electronics in manufacturing of these chips. Another expected project that we may have is by Tower, which has also submitted a proposal to set up a foundry in India to manufacture 65 and 40 nanometer chips. As I said, that the new advanced chips would be very lesser nodes, but then it's a good start for us as a country which is just evolving in the semiconductor market. The proposed investments are also coming in through a joint venture of HCL and Foxconn, investing nearly around $100 million, of which Foxconn is likely to invest around $30 billion in the semiconductor manufacturing. Then there are companies like IGSS, which is a Singapore-based venture, which will also be building a semiconductor high-tech park in Tamil Nadu. And then company called ISMC is also planning to invest in the same applications in India. So talking about the growth that we see in the semiconductor market in India as well, but there are a few challenges that we would also have to have a look at, the primarily being technology. We will introduce 65 nanometer nodes of chips in India, but then gradually we'll have to move to the smaller nodes and probably the 3 nanometer chips, which will be in huge demands for all of these applications. Purity is one major concern that the semiconductor companies also showcase. All the products, starting from the raw material value to the end products to the equipments, all require high purity standards, and that is where GFL is also coming in with all these products. Another is the supply chain. Considering semiconductor profits as a business, in a country, you need the entire value chain to be set up in the same country. It's not going to be possible if you're manufacturing chips in India, but then you're buying the chemicals from countries like Japan. It will not hold any profits for you. Then the supply chain needs to be developed. We, as GFL, are going to be an integral part in all the polymers that will be supplied in these semiconductor applications. So talking about the fluoropolymers, which is my main agenda of talk today, at GFL, as I already mentioned, we produce high purity and industrial grades of fluoropolymers, be it PTFE or PFA, that are used in these applications. If you see in the slide, there are 6 to 7 processes of semiconductors that are involved from the start to making the chip, whether be it CVD, the photoresist, etching and cleaning systems, CMP, and the DI water handling. So as you can see in the slide, the fluoropolymers are an integral part of all of these supply chain values. We have products that are used in the finished components, semi-finished components, and the other applications as well. So just to talk about, we have a lot of products for the semiconductor application. For the past 2 years, 3 years, we've been developing that. But I'll just go through one of those products, which is PFA. We've been supplying PFA industrially to a lot of companies over the past 5 to 6 years. The only reason being it has high standards of purity and performance. It minimizes the risks of contamination, which is a major concern for the semiconductor applications, and also reduces on-water defects and safeguards process integrity. So you can see all these products that are used in the semiconductor applications made out of these fluoropolymers, be it tubes and piping systems, vessel linings, wafer handling storages, coatings, and all these membranes. So just a look at the portfolio of PFA that we have right now. The service temperature range from minus 200 degrees to plus 260 degrees, which make it very compatible for chemical inertness, outstanding slip and release characteristics, and excellent electrical properties as well. These are the products that we are already supplying. I mean, the raw materials for these products, we are already supplying to companies in Japan, Korea, and overseas, wherein they manufacture all these products of cassettes, washing tanks, which are used in the semiconductor applications. Talking about our specific grades for the semiconductor applications, we as a company are also very excited to produce high purity grades of PFA 8003 HSP and 8015 HSP, which are validated, tested, and approved by semiconductor companies across the globe. The major reason being the F57 and C90s are two critical specifications that are required by the semiconductor companies, and we compliant to both of these. I would just like to finish with some of our production and lab facilities that we have. I already discussed our global presence, the manufacturing facilities that we have across India. We bring in 3 decades of expertise in polymerization. We are equipped with world-class equipments for producing high-purity chemicals and the industrial chemicals as well. We have a lot of high-tech sorting equipments so that no contamination moves in from the raw material to the end process of chip making. And then we have advanced testing laboratories. We have state-of-the-art laboratories to test all these materials. We have in-house machineries that are required for the semiconductor testing applications. Finally, coming into the semiconductor market, you have to have regulatory compliance with you. One of my colleagues already discussed. I would just like to reiterate that we have all the regulatory compliance that are required, not only in the semiconductor market space, but in industrial space as well. You talk about ROHS, you talk about ECA, you talk about FDA. All these certifications are something that we are already having with us, and that is why they make us very equipment for the semiconductor application. That is it for my presentation. I know we're running a short on time, but I would be very much open to discuss and talk about any kind of collaborations and questions that we can have on this segment as well. Thank you.